Hello everyone, and welcome to this introductory video about chromatography. Today we will cover the basic principles, common techniques, and basic chromatogram analysis. So, what is chromatography? Chromatography is a technique that separates compounds based on their interaction with the stationary phase. Most columns have a stationary phase based on silica. Secondly, we have a mobile phase or eluent which we pass through the stationary phase to drive the elution. Finally, the eluate is what comes after the column and what we collect. Depending on the type of stationary phase, that is, the type of interaction between the compounds and the stationary phase, we can differentiate between 5 basic types of chromatography. First, in the adsorption chromatography, a solid stationary phase and a liquid or gaseous mobile phase are used. Solute is adsorbed on the surface of the solid particles. This means that the more strongly a solid is absorbed, the slower it travels through the column. This is the most common type of chromatography, and we will cover it in a bit more detail at the end of the video. Next, in the partition chromatography, a liquid stationary phase is bonded to a solid surface, which is typically inside of the fused silica column. Solute equilibrates between the stationary liquid and the mobile phase, which is typically a flowing gas. Similar to the absorption chromatography, the more strongly a solid interacts with the stationary phase, the slower it elutes. In an ion exchange chromatography, ions are covalently attached to the stationary solid phase, which is usually a resin. When we pass a liquid mobile phase through the resin, solute ions of the opposite charge are attracted to the stationary phase. Ion exchange chromatography can be particularly useful for separation of proteins. In size exclusion chromatography, which is also called gel permeation or gel filtration chromatography, molecules are separated by size. In an ideal case, there is no interaction between the stationary phase and the solute. Rather, the stationary phase is porous and large molecules stream past without entering the pores, while the small molecules take longer to pass through the column because they enter the gel and therefore must flow through the larger volume before leaving the column. Finally, the affinity chromatography is the most selective kind of chromatography, which employs specific interactions between one kind of solid molecule and a second molecule that is covalently attached to the stationary phase. For example, the immobilized molecule might be an antibody to a particular protein. When a mixture of proteins is passed through the column, only the protein that interacts with the antibody will bind to the column. Now let's take a look at where we can apply these chromatography types. First, adsorption chromatography can be done in the form of a thin layer chromatography, or TLC for short, and is commonly used to track the progress of reactions. Then, we have a gravitational column chromatography used to separate compounds from a mixture. Similarly, we can find in high-pressure liquid chromatography, or HPLC, which is typically used for quantitative analysis. Partition chromatography is almost exclusively used for gas chromatography, although some partition columns can be found for HPLC as well. For a more in-depth overview, please find our videos about these two instruments. Ion exchange chromatography is typically performed by loading a resin in a column and then eluting it, but some automated systems also exist. Most common application of gel permeation chromatography is to analyze the polydispersity of a small polymer sample, and this can be done on an instrument like the one you see on the screen. However, in order to separate and collect solutes of different size, one can use a recycling GPC, where you cycle the mixture several times through the stationary phase before collecting. Finally, for the affinity chromatography, specific solid phases can be purchased and loaded in a column in order to separate specific compounds or proteins. Now let's take a look at how we can track the separation of the compounds. Suppose that we have a column filled with silica as a stationary phase and that we have a mixture of compounds A, B, and C of increasing polarity. We can load this mixture onto the column, and in order to track the separation, we can construct a chromatogram. Solids eluted from a chromatography column are observed with a detector at the end of the column, and we can plot the detector response as a function of elution time. This graph is called a chromatogram. Now we start eluting, and the first thing we can observe is that the compound A will travel faster through the column as it is least polar and therefore has the weakest interaction with the stationary phase. Next, we continue eluting, and eventually compound A will pass through the entirety of column and through the detector, which gives a peak in the chromatogram. Compound A can now be collected and removed. Also, compounds B and C have begun separating as B is less polar than C and will travel faster. When we elute further, compound B passes through the detector, giving rise to another peak. We can then collect and remove B. Finally, compound C is also eluted and collected. Let's now take a closer look at the chromatogram and what information we can obtain from it. First, we can note the retention time of each compound, which is the time that elapses between the injection of the mixture onto the column and the arrival of that component at the detector. Retention volume is the volume of mobile phase required to elute a particular solute from the column. Mobile phase, or an unretained solute, travels through the column in the minimum time possible, T0. The adjusted retention time for a retained solute is the additional time required to travel the length of the column, beyond that required by the solvent. We need this adjusted retention time in order to calculate the retention factor, which is just the ratio of the adjusted retention time and T0. This gives us unitless value that is independent of the column length. And with that, we conclude this introductory video about chromatography. For additional information, we recommend the following analytical chemistry textbook. Thank you for watching.